Hi everyone, welcome to another exciting lesson. We are going to look at this question, how to solve this algebraic expression 2 raised to power x plus 1 minus 2 raised to power x minus 1 equal to 20. What is x? So to find x, the first thing we need to do is solution. So from here, we have from our question 2 raised to power x plus 1 minus 2 raised to power x minus 1 equal to 20. So what we need to do first is to consider our rule of exponents, which implies if we have a base a raised to power m plus n, it can be separated as base a raised to power m multiplied by base a raised to power n. So considering this identity, we apply it to the left hand side. So we have 2 raised to power x multiplied by 2 raised to power 1 minus 2 raised to power x multiplied by 2 raised to power minus 1 equal to 20. So from here, the next thing we need to do is to consider this by looking at the expression and find out that we have 2 raised to power x common. So we can factor out that 2 raised to power x, put our bracket. So 2 raised to power 1 equals to 2 minus 2 raised to power minus 1. Close the bracket, equal to 20. So the next thing we need to do is to put this in this form. 2 raised to power x bracket 2 minus, so this go to 1 over 2, considering another rule of exponents. So we have equal to 20. That rule of exponent also implies that if you have a base a raised to power minus 1, you can write it as 1 over a. So this rule is applied to what this from here to here. So the next one, what we need to do next is to simplify what we have in the bracket. So we have 2 raised to power x. If we simplify this, we result to what? Let's say over 2. This will be what? 1. 2 divided by 1 equals to 2. So we have this 2 multiplied by 1. We have 2 here. 2 multiplied by 2, we have 4. 1 multiplied by 1, we have minus 1 into bracket equals to 20. So if we subtract this, we have 2 raised to power x. Then we have this to be 4 minus 1, will give us 3, then over 2. So we multiply, which is equal to 20. Now here, we need to consider this. We want to isolate 2 raised to power x. So to do that, we multiply both sides by the inverse of 3 over 2. We multiply it by the inverse of 3 over 2. So we have the inverse to be 2 raised to power x multiplied by 3 over 2, then multiplied by 2 over 3. This 2 over 3 will be the inverse of 3 over 2. That will be equal to 20 multiplied by 2 over 3. So why this one will cancel out this will also cancel out this. So we are now left with 2 raised to power s equal to, we multiply this, we have 2 times 20 will give us 43. So from here, what we need to do next is to apply log to both sides. So we have log of 2 raised to power x equal to log of 40 over 3. So over here, we apply the rule of identity of log. We apply the identity of log for both sides. For the left hand side, the identity we are going to use is, if we have log of b power a, so it can simply be expressed as a log of b. So we apply this identity to the what? Left hand side over here. So what we need to do here is to also apply another identity, which implies if you have log of a over b, it can simply be expressed as log of a minus log of b. So this will be also applied to the what? To the right hand side. So for the next step, we are going to arrive at log 2, that is x, by x coming to the base. So x log 2 will be equal to log of 40 minus log of 3. So we need to isolate x now from the next step. So we divide both sides by what? Log 2. So we have divide by log 2. Also divide this by log 2. So now from the left hand side, this cancels out this. So we are now left with x equal to log of 40 minus log of 3 over log of 2. So from here, the next thing we need to do is to we can simplify the log of 40. So we have log of 40 can be simplified as log of 10 multiply log of 4 multiplied by 10 minus log of 3 over log of 2. So this is what we have in our next step. So this can also be expressed. This, we can simplify this as well. So we now have this to be, by using another, we can simplify this by using another identity of log, which implies that if you have a log of a multiplied by b, you can express it as log of a plus log of b. So this identity will be used. This identity will be used to what? To simplify this aspect. So from that, our next step becomes x will be equal to log of 4 plus log of 10 minus log of 3. All together will be over log of 2. Now we can now put this in this form. X will be equal to log of 4 over log of 2 plus log of 10 over log of 2 minus log of 3 over log of 2. So here, this can be simplified as x. So this can also be simplified as log of 2 raised to power 2 over log of 2 plus log of 10 can also be simplified as log of 2 multiplied by 5 over log of 2, then minus log of 3 over log of 2. So here, these two will come down to the base. Then we have 2 log of 2 over log of 2 plus log of, so this also we use the previous identity. We have log of 2 plus log of 5, okay, log of 5 over log of 2 minus log of 3 over log of 2. So here, this we cancel out with this. We now have the next step to be equal to x equal to 2. It will be left with x plus log of 2. We can also split this over log of 2 plus log of 5 over log of 2 minus log of 3 over log of 2. So as you can see over here again, this cancels out this, and that becomes 1. So the next step becomes x will be equal to 2 plus 1 plus log of 5 over log of 2 minus log of 3 over log of 2. This is the next step. So x equals to this. So we can add this together, and we have 3 plus log of 5 over log of 2 minus log of 3 over log of 2, which is equal to s. So here, what we do here now, we need to simplify this and this in the form of, if you have an identity of log A over log B, so we express that as log base B A. So this is the form in which we are going to put this term and this term. So our x now become x equal to 3 plus log 5 base 2 minus log 3 base 2. So this is going to be our value of x. Is going to be our value of x. So what we need to do to confirm this value, the correctness of this value, is to verify this. So we have to verification. So here we need to verify this value. From our previous expression, we have x2, we have 2 raised to power x plus 1 minus 2 raised to power x minus 1 equal to 20. So if we insert the value of x into this equation, we have 2 raised to power 3 plus log of 2 base 5 minus log of 2 base 3 minus 2 raised to power 3 plus log of 2 base 5 minus log of 2 base 3 minus 1, all equals to 20. So now here we simplify this expression. So we have 2, so this plus 1, okay, plus 1. So we have 2 raised to power, so we can add this plus this together. So we have 4 raised to power 2 raised to power 4 plus log of 2 base 5 minus log of 2 base 3, then minus 2, we can subtract this 3 and minus 1. So we have raised to power 2 plus log of 2 base 5 minus log of 2 base 3, all equals to 20. So now we have to apply this rule. If we have base A power m plus n, we write them as resulting answer to be base A power m multiplied by base A power n. So we are going to use this identity again to simplify this. So from here, this can be written as 2 raised to power 4 multiplied by 2 raised to power log of 2 base 5 multiplied by 2 raised to power minus log of 2 base 3 minus 2 raised to power 2 multiplied by 2 raised to power log of 2 base 5 multiplied by 2 raised to power log of 2 base 3 equal to 20. Now from here, we can now rewrite this as 2 raised to power 4, then multiplied by 2 raised to power log of 5 base 2. This will now become the denominator. So we have 2 raised to power log of base 2, 3, then minus 2 raised to power 2 multiplied by 2 raised to power log of base 5, 2. Then this as well is what is a negative when we consider this from here. So this will be negative. So minus raised to power minus log of 3 base 2. So we bring that to the denominator here as well. 2 raised to power log of base 2, 3 equal to 20. Question mark. Will that be so? So from here, the next step becomes 2 raised to power 4. So 2 raised to power 4 multiplied by 2 raised to power log of 5 base 2 over 2 raised to power log of 3 base 2 minus 2 raised to power 2 multiplied by 2 raised to power log of base 2 5 over 2 raised to power log of base 2 3. Will that be equals to 20? So this and this and this and this as well will become this when we apply this identity. If we have base A raised to power log of base A B, it can be written as B. So the resulting answer can be written as B. So we can see we have base 2 raised to power log of base 2 3. So it's in this form. So it means the next step becomes 2 raised to power 4 will give us 16 multiplied by, so this will become 5 over, this also become 3 minus, this become 2 raised to power 2, we have 4 multiplied by, we have 5 over, this also become 3. Will that be equal to 20? Okay, 16 multiplied by 5 will give us 16 multiplied by 5 will give us 80 over 3. 80 over 3. Then minus 20. 4 multiplied by 5. We have 20. Then over 3. Will that be equal to 20? So we can simplify this as everything over 3. Then this will give us 80. So 80 minus 20, will that be equal to 20? So 80 minus 20 will give us 60. Then divided by 3, will that be equal to 20? So if we divide 60 by 3, we now have 20, which is equal to 20. So as you can see, the left hand side equal to the right hand side. LHS equal to right RHS, which proves that the value of x is correct for x equal to 3 plus log base 2 5 minus log base 2 3. Thanks for watching. Stay tuned for the next interesting lesson. Do enjoy yourself. If you like the video as well, subscribe to the channel, like the video and share it to your loved ones. Continue with the next lesson on your view.